we'll cover the problem finding the boundary with binary search on AlgoMonster. So for this problem, we'll be given an array of booleans just like this. Just like this one here. And it will contain kind of two sections. The first section will contain all false values, and the second section will contain all true values, and they must be in this order. So we could not have a false value like over here, for example. This section, once we see one true, they must all be true. And our task is to return the index of the first true element. So in this case, it would be this true right here, and so we return index 2. If there is no element in the array that is true, then we return -1 here. The easy way to do this would be start at the very beginning and iterate forwards until we find true. However, if we had an array that had 10 million elements in it and the very last boolean was true, then we would iterate over 10 million items to find that. But we can use binary search so that we only have log of 10 million iterations, which is quite a bit better. And so I will go ahead and get into the code for this because I think it will help illustrate the algorithm and it'll become clear as we code it. First thing I'm going to do is I'm going to grab the last index of our array. Then we'll have our left and right indices. Left starts at 0 and we'll have right start at the last index. So at this point in time, we are kind of considering the entire array in our search space. We also need some sort of variable for our result, the answer we're going to be producing. So in this case, we're finding the boundary, the beginning of this section of truths, and they're calling that boundary here. So I'll name that boundary index. We'll initialize that to -1 because if we never find a real boundary, then we're just not going to overwrite it. And so I'll create a constant called noTrueElement, which is -1. And we'll initialize boundary index to be that value, no true element. Then we'll say so long as left index is less than or equal to right index, we want to do some logic. Here, we'll grab our mid index. I'll write a function get mid index that does that for us. So it just takes in our two values. We can go ahead and write that function right now. So we'll come up here, declare a function, take in a left index and a right index, and we'll grab our mid index. Now here we're going to use our math because we want to be careful for the case where there's potential integer overflow, where the integers get really, really big. I think we want to parentheses here. And when the integers get really, really big, we don't want to kind of combine them and then divide by 2 because they might get really big after combining them. So we just kind of find the difference between them, cut it in half, and then add that to the left index, which is the smaller one. Then we can return our mid index. We also want to grab our mid value, whatever value is at that index. So we'll do array at mid index. And now here we have two conditions. The boolean can either be true or false. So first, let's handle the case where it's true. If it is true, then we know that the true boundary, let's say this is our current index. If this is true, which it is, then we know that our boundary index, the first true element, must be either where we are or it must be to the left of us. It cannot be to the right because those elements are all greater than our current position. So we want to be searching the left chunk here. So what we'll do is we'll move our right boundary inwards, our right index inwards to search the left chunk of the array. So we'll say right index goes to the left of wherever I am right now. So we're reducing the search space from, like, basically if we're currently on this element, we're saying, all right, now this is going to be our search space because we've already validated that this is this leftmost true element out of the remaining chunk of the array. Now, the other information that's important here is that this guy, since this element is true, it could be our boundary index. So what I'm going to do is I'm going to write boundary index equals whatever our mid index was. Now, you might be thinking, this is not actually the right answer. This is not our boundary index. And that is correct. There are two cases for what is going to happen after we set the boundary index here. Case number 1 is that this was the true boundary index. This was our answer that we wanted to return. In that case, when we search the left chunk of the array, we will never find an answer because we had already found our correct answer. And so we will not overwrite boundary index, and we will keep it at the value that we set, and that is exactly what we want to happen. The other case is that what we actually saw here. So we set boundary index to be this value, but actually there's a better answer. But if we reduce our search space to, like we set this to be the boundary index, and then we reduce our search space to everything to the left, then we're going to find another true value, and that true value is going to overwrite the boundary index. So the fact that we set boundary index to be this true, or 3, doesn't actually matter. It will be overwritten. So if we set boundary index correctly, it will never be overwritten and we're good to go. If we don't set it correctly, it will be overwritten. So it's completely fine for us to be setting it here. Now we have to handle the other case, which is what if we find a mid value that is not true, so something like this. Well, then we know we want to search everything to the right of us. So we can kind of grab our left index, and we're going to move it over to mid index plus 1. So then we search the remaining chunk of the array that is to the right of our current mid index. Then, this is all we need in our loop. In the end, we're simply going to return our boundary index. So this process up here is just going to be kind of continuously repeated until we find our answer, or if there is no answer, then our indices will eventually cross because of the math we're doing here, and then we'll run into some problems. So let's go ahead and see if this works. Hopefully it does. Okay, looks like it does work. Now I want to quickly emphasize one thing, which is that this right here, this template can be used for lots of binary search problems. This idea of let's find the very first occurrence of some condition. And the condition is not always going to be as simple as find a true or false value, but the template actually looks the same even when the conditions are more complicated, which you will see in the future problems. But for now, I would really focus on learning this template, understanding why it works, and being able to code it without too much difficulty. Alright, well that's all for this video, and thank you for watching.